Hello everyone, welcome to my class, Math Lesson with Miss Kenny. This is video part 2. In this video, I'm going to explain how to solve linear inequality problems. For example, solve the following inequality and illustrate your solution on a number line. As you can see, the first thing we need to do, we need to isolate the linear term, the x, the unknown, by using balance method. So I put -3 on the left side of the inequality sign. If I put -3 on the left side of the inequality sign, I need to put -3 on the right side of the inequality sign. So x is less than 4. This is the solution. And then illustrate on a number line. Take a look at the number on the right side of the inequality sign, 4, and then use open circle since the inequality symbol contains no equality. And then look at the inequality symbol again, and this looks like an arrowhead pointing to the left. So the solution is on the left region here. As you can see, you can check the answer whether this is the correct answer or not by picking a number, for example 3, a number on the shaded region 3, and use it into the inequality here. So 3 plus 3 equals 6. 6 is less than 7. That's true. So this is correct. So the second example. What if the linear term is on the right side of the inequality symbol? So first we need to isolate the linear term by using balance method. And then we simplify. So we get 2 is more than x. I want to put the linear term on the left side. So I reverse the order. If I reverse the order, I need to change the direction of the inequality symbol too. So from pointing to the right, it becomes pointing to the left like this. So this is the solution. And now illustrate the solution on a number line. So take a look at the number on the right side of the inequality sign. 2. Use open circle. And then the inequality symbol looks like an arrowhead pointing to the left. So tells you to go to the left and then shade the region. You can check also by picking a number on the shaded region and use it into the inequality to find whether it's true or not. So if the linear term is on the right side of the inequality sign, we need to change the place. So what about if not only the linear term is on the right side of the inequality sign, but the linear term is negative? First, we need to isolate the linear term. Okay, and simplify. So we need to reverse. I want to put the linear term on the left side. So I reverse the order. If I reverse the order, I need to change the direction of the inequality symbol. And then to remove the negative sign, here I need to multiply each term by -1. So it will be x. Since I multiply by a negative number, I need to change the direction of the inequality symbol. So x is more than -24. This is the solution. So if you reverse the order or you swap places, you need to change the direction. And if you multiply each term by -1, you need to change the direction of the inequality symbol too. Now illustrate the solution on a number line. Take a look at the number on the right side of the inequality sign, -24. Use open circle, and then the inequality symbol looks like an arrowhead pointing to the right. So the solution is on the right side of the number line here. You can check by picking a number on the shaded region and use it to calculate the inequality, whether it's true or not. So this is the fourth example, a compound inequality. As you can see, the linear term in the middle, the coefficient of the x is not equal to 1. So we need to change the coefficient of x into equals 1. So we need to divide each term by 2. So we simplify, we get 2 is less than, x is less than or equal to 4. This is the solution. Now we are going to illustrate the solution on a number line. Start from 2, use open circle, and then 4, use close circle, and then draw arrows. The solution is between. So we shade the area between 2 and 4. You can check whether your answer is correct or not by picking a number in between, whether it's true or not. Now the fifth example is a compound inequality. What about if not only the coefficient of x is not equal to 1, but there is a +1 here? So we need to isolate the linear term using balance method and then simplify. After we simplify, we need to divide each term by 2. So we get 1.5 is less than x is less than or equal to 3.5. Now we can use the number line to illustrate the solution. Okay, you can use only two numbers here, 1.5 and 3.5. And then use the open circle for the 1.5 and close circle for the 3.5. And then throw arrows, shade the region between 1.5 and 3.5. Again, you can check whether your answer is right or wrong by picking a number between 1.5 and 3.5. Check whether the solution is correct or not. Okay, this is the last example. What about if the linear term is negative in this compound inequality? The same with the linear inequality. To change the negative sign to positive, we can multiply by -1 or divide by -1. If you divide by -1, it will change not only the sign of the number or the sign of each term, but it also change the direction of the inequality symbol. So from pointing to the left, both pointing to the left become pointing to the right. And since I'm using the order where the left side is the smallest and the right side is the greatest, so I need to reverse the order again. Okay. If you reverse the order, you need to change the direction of the inequality symbol too. So like this. This is the solution. So if you divide each term by -1, not only the terms are changing, the sign are changing, but also the inequality symbol also change in direction. So now let's put this in on a number line. negative 4 on the left, use open circle, and negative 2 on the right, use closed circle, and then draw arrow, and then shade the region between negative 4 and negative 2. This is the solution. You can check whether your answer is right or wrong by picking a number between negative 4 and negative 2, whether it satisfies the inequality or not. Okay, that's it for today. Thank you for watching Math Lesson with me, Kenny. Bye-bye.